Then we'll look into what is platform as a service all about, and what are the various offerings that especially AWS Amazon Web Services provides for platform as a service. We'll be dealing little deeper into Amazon Web Services, Elastic BeanStalk, and CloudFormation, because uh, today's topic. Then we'll look at what is the typical enterprise architecture today and what are its limitations. And then we'll look at what would be the optimal enterprise architecture which would leverage today's cloud services, and how it would help us to take care of the limitations of legacy architecture. Then we'll summarize the best practices, and then we would have a short Q&A wherein you could type in the questions in the chat, and our administrator would take it up. So introducing Compassites. So Composite Software Solutions Private Limited was founded in 2005 with the mission to amplify customer success through the passionate navigators. Our developers are called navigators, and uncommon social responsibility, keeping the technology and innovation at its core. Our expertise includes cloud enablement services, cloud computing services, wherein we help customers enable their applications for the cloud, like Amazon Web Services, Windows, Azure, Google App Engine, and such. We deal with one of our expertise is business big data analytics, wherein we deal with NoSQL, MapReduce, with Hadoop, MongoDB, Modrian, and all. Uh, Another expertise is consumerization of IT, and then technology consulting, wherein we deal with leading edge technologies. Composite Software Solutions does its projects in an agile way, and we follow Scrum. And in last 7 years, we have fostered around 25 software products in various domains and various technologies. Some of them which you would have already heard of or used are like iCharts. We have done Authentics, GFL. We've done some social enablements for ICICI Bank. We have done another tour, Informatics, Transformers, Acrovit, Sagestica, to name a few. To speak about speakers, I'm Girish Karachiwala. I'm head of technology at Composite Software Solutions. With over 14 years of experience in IT, I'm passionate about creating very simple and innovative technology solutions to the complex business problems. I worked in the areas or provided the high-end enterprise level solutions to the domains like pharmaceutical, banking and finance, securities, insurance, customer relationship management, and all. Yatin was the chief architect at cloud computing at Compassites. He's our second speaker. So Yatin has over 17 years of hands-on experience in architecting and implementing internet, intranet, and desktop enterprise applications for the customers across various continents. Last 4 years, Yatin has been focusing on applying various cloud technologies to domains such as map data management, enterprise content management, and exchanges. So I'll be giving the introduction to those various technologies, and then Yatin would delve deeper into the challenges with our today's or legacy enterprise architectures, and how to leverage the cloud services to come over these limitations. So what is cloud? So it is really difficult to define cloud. There are so many several definitions floating around. Wikipedia says that cloud is the use of computing resources. They may be hardware or software that are delivered as a service over the network. The word service here says that these are delivered on demand and on a pay per use basis. So basically, this cloud computing can be categorized into three broad delivery models. I'm sure most of you, being architects and developers in the audience, would be aware of them. The first delivery model is infrastructure as a service, wherein the cloud providers basically provide you the hardware servers, virtual machines, storages, databases, firewalls, load balancers over the network on a on-demand pay-per-use basis. So basically, you leverage these off-site infrastructure on the need basis, and you pay per use. After that, another delivery model of cloud computing is the software as a service, wherein the end user applications are delivered on demand to the user. Excuse me, on a pay per use basis. So one of the examples of this is Microsoft Office 365, wherein before, let's say before Microsoft Office 365, if you had to use Word, you have to procure Word, install it on your system, and then use it. And you have to take care of backing up your documents and upgrading your software and all. With Microsoft Office 365, you just have to subscribe to the service and start using it. And it itself takes care of backing up the documents and upgrading the software and all. Salesforce is another example of software as a service. Google Apps is another example of software as a service. Another new age cloud computing is platform as a service, wherein basically this platform as a service came as a boon for developers, wherein developers are provided the computing platform as a cloud service. The platform would include operating system, it could include development and the execution environments, the databases, application servers. Examples of a platform as a service would be Amazon's Elastic BeanStalk, Google App Engine, Windows Azure Computes, Cloud Foundry, and Force.com. Here, basically, the developers do not have to procure the hardware, they do not have to install the operating systems, they do not have to install the IDEs and the frameworks. They just subscribe to a service and start developing and deploying their applications. The platform as a service could also include the other services such as configuration management uh, and deployment services. So let us delve a little deeper into what is platform as a service, right? So there is no fixed definition for platform as a service as of now, but broadly speaking, this is the whole spectrum of cloud-based tools and services to be utilized by web application developers, and it is an alternative to the traditional way of acquiring hardware and software upfront and developing the application using desktop development tools, then manually deploying and managing capacity, scalability, and availability of the application. So PaaS typically offers faster, very cost-effective, cloud-based computing platforms for the developers. It also includes software lifecycle management tools, as discussed, like configuration management and continuous integration and release processes. It allows the developers to focus especially on the application expertise for the business and not on managing the complex hardware and software infrastructure, configuring and releasing the and release managements. Major players who call them PaaS providers are Windows Azure from Microsoft, Amazon Web Services, IBM Smart Cloud, Google Cloud Platform, then there's Cloud Foundry, OpenShift, and recently DataPipe, who's one of our partners in cloud computing services. So let us talk about some of the PaaS services which are offered by Amazon Web Services. Our topic today is dealing with the PaaS services provided by Amazon. So some of the Amazon is basically leading the innovation in the PaaS, which could PaaS and offers the services which become the building blocks for the modern web applications. Some of these services are Amazon relational database services, wherein it provides out-of-the-box MySQL, Oracle kind of relational databases, which themselves manage, the service manages the availability and the fault tolerance across the regions. Another service is Elastic Cache, wherein uh, it provides Amazon Web Service itself provides the caching services. DynamoDB is another NoSQL service provided by Amazon Web Services. Identity management, simple queue service, simple workflow services being another PaaS applications. The two that we are going to deal today is Elastic Beanstalk and CloudFormation. So Elastic Beanstalk is an easier way for you to quickly deploy and manage the applications in the AWS cloud. So what you need to do is simply upload your application to an Beanstalk instance, and it automatically takes care of capacity provisioning, load balancing, auto scaling, and application health monitoring. You just have to create your WAR files or the application deployments and upload it to Beanstalk, and it takes care of your application. So Elastic Beanstalk basically leverages Amazon's IaaS services like EC2, then S3, simple notification services, elastic load balancing, auto scaling to deliver the scalable, highly reliable, and cost-effective infrastructure. The advantage of Elastic Beanstalk is that unlike other PaaS providers, the developers retain the full control over the AWS resources that are powering your application. So let's say if you decide to take control of the elements of your infrastructure, you could easily do so using Elastic Beanstalk, and then manage themselves and have full control over the applications, which a lot of other PaaS providers might not provide you. Then AWS CloudFormation gives the developers and administrators the easy way to create and manage the collection of AWS resources. Your applications in most of the cases consist of several of the elements, right? Several servers, cluster of several servers and components. So you could basically create the template of your related AWS resources and use it as in CloudFormation, and developers could easily use this templates to instantiate the complete cluster of the servers, cluster of the related AWS resources, and start running your application. So once it is deployed, then you can easily modify and update your AWS resources in a controlled manner, a predictable way. And AWS CloudFormation basically does the uh, version control management of the infrastructure just as you would do for the for your software. Um, so these were the services, past services that could be used in the enterprise architectures. My colleague Yatin Kulkarni is going to deal with what are the limitations of the current enterprise architectures and how you could leverage cloud services to overcome them. Handing over to Yatin.
Thank you, Girish, and once again, welcome everybody. Thank you for attending. So, in preparing for this this webinar, we decided to kind of do some research on what is out there today and what is being published now that cloud computing has been around for quite some time. And we found that most of the time the reference architectures are quite simplistic in nature. And that may be true, for a lot of the sites out there that are on Amazon today or a lot of the other providers. But typically, when you get to a real enterprise application, things start getting a bit more complex. So we wanted to try and look at an architecture, a reference architecture that was a bit more complex. And hence, from that perspective, we are looking at a architecture that is basically based on SOA. So we have our classic distinct distribution between a web app that may be hosted within a servlet container to allow for higher scalability. And then we have a bunch of shared services against a replicated data store. The services in turn may use an ESB for orchestration amongst all the services. So as it is, we are starting out with a very loosely coupled architecture. So from that perspective, we really wanted to try and see, what could be done differently. I mean, obviously, all of this can be deployed as is within EC2. So it could be deployed on any provider of infrastructure as a service. What we wanted to see is how would we take this reference architecture and then basically look at its limitations from the context of cloud deployment, and then what could we do differently. So in terms of identifying a basic set of limitations, what we identified, based on our own experiences, typically due to even starting with the web app, due to the typical monolithic nature of the deployable components, you try to package everything into a single WAR file from the ease of build and deployment. You end up requiring larger virtual machine instances. You cannot really leverage the cheaper, or ideally we would even want to leverage the free micro instances, just because they are simply not sufficient for what your application needs. The same then applies obviously for the service layer, because again, with the introduction of ESB and reliable messaging and everything, your basic minimum requirements start going up, and hence you need bigger and bigger instances. This, of course, increases your cost quite significantly. Secondly, from an auto-scaling perspective, your options are limited. Obviously, Girish has talked about Elastic BeanStalk in terms of the benefits it provides, but one of the restrictions of BeanStalk, for example, is that it only deals with very simplistic stacks today. So you might have the standard LAMP stack, or some very basic PHP-based apps. So it's again not very suitable for deployment of something along the lines of SOA. So you're in a traditional architecture, your auto-scaling options get limited. Thereby, again, you have a potential for increasing your cost. Data store replication, again, here assuming you're still sticking to your traditional databases deployed within the cloud. You have to arrange for replication, which then becomes vendor specific, and either you would rely upon managed services, or you might have to undertake extensive configuration to ensure that replication is happening. Static content delivery, you also end up having to deal with separate instances for that, so as to make sure that you are able to deliver all your static content quite effectively. And all of this then eventually results in a pretty complex deployment process. This is kind of where we are trying to rope in CloudFormation to try and help on that. So these, obviously you can think of a lot of other limitations possibly as well, but this is kind of at the high level what we wanted to lay out as limitations. And when we enter the Q&A session, we would be more than happy to hear from you as to what other limitations you may have encountered. So now, keeping these limitations in mind, and then keeping specifically Amazon offerings in mind, since we are focusing today on Amazon offerings, what we have tried to do is come up with an optimal architectural recommendation for the same application that we just talked about, but then kind of repackaging it, re-architecting it to really leverage the different services that Amazon is offering as a part of its PaaS offering. So immediately, one thing that you would see here is that instead of a monolithic web application, we are proposing that we modularize the overall web application. And what we really mean by that is that typically within a web application, you would have different usage patterns across the different parts of your application. So even if let's say it's an e-commerce site and you have support for a shopping cart, you'll probably find people are doing more browsing and less shopping cart management and checkouts. Although we would like to have more checkouts, but that typically is the case. So by separating them out into separate modules, and by modules here we literally mean that we can split them out into separate deployable WAR files, web application archives themselves. We can basically now set up Elastic Beanstalk profiles for each individual war, and then you can even say, which war scales in what fashion. And this is where truly we can potentially aim for using micro instances. So really the idea from the separation is to really create these modules that are lightweight enough that they could potentially run within an 512 MB Linux micro instance, which Amazon offers for free, and then use Elastic Beanstalk to really scale up and down depending upon your overall load. That then basically connects through a Elastic Load Balancer to your shared services. Now, the shared services, what we are proposing here is that essentially we first of all use this concept, use the Elastic Cache service to externalize context management. And by context management, I'm basically referring to web session data management. So one thing that would happen as a part of separating out those into different wars is how would your overall web session be managed? So that's the real challenge that you have to deal with, and that can then be managed through the address to the use of an in-memory object cache, such as Elastic Cache from Amazon. And that then basically allows you to transfer context from one web application module to the next. The rest of the services would be pretty much your standard services, but again here the difference is instead of using a enterprise service bus that's a part of a particular Java EE container, we could actually then leverage some service orchestration services such as the Amazon Simple Workflow service, or other service providers also have some similar services. Azure has something, IBM Smart Cloud has something similar, and let these services, service management and service collaboration be effectively externalized from the service deployment as well. So that opens up an avenue as well to potentially host your services within simpler or smaller um, instances, and again, thereby addressing your cost. Excuse me. In doing so, one thing that we realize that happens quite a bit is that we actually rely upon services to also fetch data. That happens for a number of reasons. Typically it just makes sense to allow for everything through a service, depending upon whatever your clients are. So typically RESTful services are heavily used for fetching data. But what if essentially we actually also had a persistence shared library? So that's one of the key things that we have been toying with here, is that why can't the web applications directly access the data store through a separate persistence unit to for reading data? So the idea here is that all your obviously data rights will all be going through services, because that's what kick off different business processes, etc., and so forth. But all the data that is required for display could all be pulled directly from a persistence unit itself. So that was one of the main things that we also thought could basically benefit um, this architecture in terms of cloud deployment. And then, of course, from a data store perspective, we have cloud-based data storage from Amazon RDS, Amazon SimpleDB, Amazon MongoDB. Uh, so all of those basically then allow you to have replicated fault-tolerant data stores without the need to actually have vendor-specific replication setups and things like that. So this is kind of where we are kind of thinking about how a traditional architecture can be broken apart even further. So as it is, we are starting off with a very loosely coupled service-oriented architecture, and then by doing further decoupling through the use of services provided by the cloud, we feel that there is a much greater scope for optimal usage of cloud resources, especially trying to utilize the free EC2 instances instead of relying upon large paid instances. So based upon this discussion so far, what we can then summarize the best practices as is coming up. So summarizing the best practices, you want to definitely try and modularize your web components based on extended expected usage patterns. Obviously, in doing so, we do appreciate the additional complexity to potentially deploy how the entire build and deployment process yeah, would change. But again, that is where what we have been talking about in terms of the cloud formation, we feel that that can address those concerns to basically ensure that the more complex deployment can be handled more easily. We then talked about externalizing session management via the use of an in-memory cache. So an in-memory object cache is something that everybody recommends for the use of, to overall speed up your application. So it is already a standard part of the application from the perspective of just speeding up overall access to data. But in addition to that, what we're also saying is externalize session management from within the web application into that object cache as well. So that will then also provide for this whole ability to transfer context from one web module to the other web module. Then we talked about this whole concept of read-only access to business object model entities. And this we feel is really the key to ensuring very fast performance and reducing the overall load on your service model. So that persistence shared library could actually be deployed along with your web applications themselves. Um, we also want to emphasize, obviously, on some of the more classic best practices. So this whole concept of fault tolerance has to be incorporated in. So one of the things that we dealt with in a project that's ongoing over here is we wanted to use a centralized ID generation service, and potentially there were issues about concurrency access and things like that to that service. So what we were talking about is essentially why does a persist operation, have to give up on the first try? So why not even some build in some at a very low level, potentially build in some retry functionality so we could actually address some deadlock kind of a concept if at all it comes up, and thereby make the whole thing more tolerant and more scalable. So that is something that I've also seen that being recommended in other best practices. So we are kind of incorporating that over here as well. Then at the same time, we are also are saying that static content delivery should really be modified to leverage WebDAV and then hence be able to use services such as S3 or CloudFront that would then allow you to deliver that static content very effectively. So static content sometimes also refers to content that actually got generated from within the application. So sometimes you generate some snapshots of charts or something else within your application that you want to use as a first level of preview. So something like that can also be all pushed into this CDN services, so enable delivery in a more efficient and more reliable and distributed manner. Finally, one of the other things that we want to propose and give further consideration to is extending the whole identity and access management services that the cloud provides. Now, the trick here is that those are typically actually meant more for um, managing access to your cloud resources themselves. So if you look at the typical use cases that Amazon talks about for identity and access management is more just about, hey, how do you manage all your AWS resources and control access to who goes in and does what? But what we're saying is why not even extend that a little bit further to your application? And that with the introduction of, federation in identity management, where even the Amazon access can be then combined with your Active Directory in your enterprise. We see a potential wherein essentially security can be made more seamless. And if it is extended in that same manner to your application, you could actually eliminate a need to have a separate security model and have to worry about and eliminate the whole need to actually dedicate resources within your application just to managing security. So this is kind of what we have summarized from a best practices perspective. It goes beyond the obvious. So if you are typically dealing with a very simplistic web application, um, individual services like Elastic Beanstalk would definitely do the trick. You would not have to really go deep into using the other services that Amazon has to offer. But in any realistic enterprise application, we feel that you really have to look beyond just one service and really have to look at creative ways of combining a lot of these different services that we talked about and incorporating them into your enterprise application. Of course, different providers have different flavors of the same services. Not every cloud provider is alike today. Not everybody may be providing exactly the same set of services. So that is something that we are definitely cognizant of. At the same time, we do have the unique opportunity to be working with a cloud provider in a value-added reseller role, as well as a development partner, and that is the data pipe, where we have already had a number of discussions wherein we could create some custom services, which would then also be hosted in the cloud enabled manner through data pipe that can address your unique requirements. So please do talk to us, and we can definitely figure out the optimal way to apply these best practices to your particular business needs and problems. Um, that's all we have for today's session in terms of an overall presentation. So we can now entertain questions from the audience. And once again, thank you very much for your time today.